So welcome again. So we'll try to leverage the pointers of a slice today to avoid cloning of the entities. So I am trying to prepare the test environment to have all the design. So I renamed the original function that what we had as drop head at position with the cloning, and I have just copied the drop headed position again so that we can compare how we progressively evolve the design. This time using a pointer, so no cloning. So we made the compiler to help us by showing the areas we have to modify. Now the slice 0.clone is something we don't want. So we have to get the head somehow more like a bitwise copy. So we will first obtain the pointer to the entity at slice 0, and let us call this as a head pointer. Now we have the head pointer that is pointing to the buffer, and there is a method called as copy non-overlapping in the std pointer crate or core pointer that will act something like a memcopy, which we can use to copy something from a source to a destination. So it's more of a bitwise copy. Equivalent of using an equal symbol that will move something from the right to the left. You can read more about that from the awesome documentation available along with copy non-overlapping. That is our first step towards playing with the pointer. So we are practicing the block part today, and so let us try to fix each of the problems one after the first. We want the destination where we are going to keep this. So let us try to keep this somewhere as usually a temp variable. Let us call this as a temp holder, and that should be a mutable pointer. That is, it should point to somewhere in the memory that is mutable. And copy non-overlapping will take care of what we mean by one. It is the size of one element of the entity. So we do not know what actually the size. The Rust will calculate the size on behalf of us. So we don't want to bother about that now. So it will do the required calculation for us. Now let us create a pointer somewhere in the memory. The name itself is very interesting. It is maybe an init. Okay. And which will have a method called as assume init to get the value out of that. So anyway, we'll first create a variable temp holder, and that may be an init, and let us give a type for this, and probably we may need a mutable pointer for this. So once if we have the temp holder, then we basically need a mutable pointer for this, and how to get the mutable pointer. Yeah, that is what is the signature of the second parameter. Let us use as mute pointer if possible in the temp holder. Yes. and this is equal of mem copy, and if we call the, in fact we can use the as mute pointer here, but the consequence of that will be that we cannot get the value out of that. Let me show that to you. We finally we need the head. We have to have the entity, the bitwise copy of the entity in the location 0. So if you put a temp holder here, and when we call this assume unit, which is normally the method that is available in the maybe ununit to get the value out of this. So we will do that. Let us have the asMute pointer to the non-overlapping method, and when we call this assume unit, we will get the value, that is what is living at the location 0. So for documentation, so this is the trick. So when there is no possibility of you to implement a clonable one, then probably you can resort to the copy non-overlapping. That accepts 3 parameters: the head pointer, I mean the source, and the destination. So it follows the same thing for this the slice 0 to slice destination. So we need an SRC and we need a destination, and the SRC is what is in the location number 1, and let us have this as a constant pointer, because SRC is not to be a mutable one as per the signature of the non-copy overlapping, whereas the destination naturally, that is the place where we are writing, so it should be a mutable one. So it is very interesting that you are getting a loan in an indirect way. That is the same slice we are treating at any point in time. There is only one mutable location and another one is non-mutable location. So now we have the line number 78 that says the slice 0, and we have already a non-copy overlapping counterpart on the other side. So now we will proceed to the other clone. We will follow the same trick. Obtain the pointers to the SRC and the destination from the respective indices. Are we getting this? So it should be an unsafe operation, and let us fix it. So we have to put this into an unsafe block. Before this, we have to move the head also to the, that is a final thing, that is, in fact, that is dropping the head at the desired location is what the very essence of this entire method. So let us have this head, let us get that as a constitutive, that is a source, and the destination is the index where we are going to put this. Let us quickly fix this unsafe errors. So we'll make this entire method as unsafe because there are a lot of unsafe operation we are doing here. Let us change the so now let us fix this error. Why is it showing error unnecessarily here? Okay. We can remove this line. It's again a problem of copy paste. So now we have we find a way to provide a hacky solution. Hacky, it's not a hack. In fact, it is what Rust is doing internally whenever you are doing a swap or whatever it is. So it is using this copy non-overlapping. My God, this is a problem of unsafe code. The undesired behavior is that the pointer being freed was not allocated. Okay, this is a classical error of any struct that is using a string or anything that is having its own drop. So I'll show that like this. Let us make this into a U32. It's a very classical error that whenever we are dealing with the pointer, the destructor is being called in a different order. So as there is no destructor for the string, as there is no destructor for this U32, it is not containing anything. But when we are making this into a string, what is happening is that the string is getting dropped earlier to, it should be dropped first before we are even dropping this entity. But things are not happening in that order. So a proposal was made long back in the Rust community, RFC, and they come up with the idea of manually controlling this drop. So in fact that is called as ManuallyDrop, and that is available again in the std mem, and let's use that ManuallyDrop new and this. So it will tell that first, so this will just change the order in which things are getting dropped, and let's get the reference of that different this now, so it's fine. So when you come across with this kind of errors like malloc double free, you look for areas where you can really work it out. If you're using a string, most probably you have to control the order in which things are getting dropped. So now what we can do is, there are a lot of we need not to provide this as constant t, as mut t, because those things will be automatically quiesced. For example, yeah. So the non-overlapping will, being the method signature is accepting this. So a casting is not required, that is implicit. I give the casting so that you can understand what is happening really when you are doing the copy non-overlapping. Let's check that head pointer also, that also can be passed as a slice of 0 here. So we have removed a lot of lines now, and that's it. Cool. So this is the actual implementation of insertion sort internally by Rust. So we have just reached the right design, the aid of a test, of course, and also with the help of the pointers. So we came a very long way. We just evolved the design using a clone, and then we find a very good way of this non-overlapping. This is a precursor for us to appreciate the tip sort implemented by Rust. Again, thank you so much for watching, and let us meet on another session where we'll discuss about tip sort. Thank you.